Assalamualaikum and a very good day to Dr. Barirah and also my fellow friends. Today I'm going to present about cellular concept, cellular architecture and also frequency reusing. Um, so my group consists of Windy, Siti Rahima, Zaha and also myself. Okay, first we start with a cellular concept. An early mobile radio system was designed to achieve a large coverage area by using a single high power transmitter, which is that this design cannot reuse frequency. But the problem faced with this architecture is that spectrum allocations in proportion to the increasing demand for mobile service. So the concept here that being used in the cellular is the solution to solve the problem is spectral congestion and user capacity. So the cellular concept is depends on many low power transmitters, or we call it a small cells, each providing coverage to only a small portion to the service area. As you can see here, the cellular concept of these the small cells that will provide a small portion to the service area. So each base station is allocated a portion of the total number of channels available to the entire system. The nearby base stations are assigned different groups of channels. To minimize interference between base station and the mobile users under their control. So the function of the small cells is to minimize the interference between base stations. How this is done by the small cell? By systematically spacing base station and their channel groups, that the available channels are distributed throughout the geographic region and may be reused as many times as necessary, so long as the interference is in acceptable level. So what does it means that based on this point, this is the condition that we need to satisfy in order to for the small cell to work. So we move on. As the demand for the service, the number of base stations increase. So by this, providing additional radio capacity with no additional increase in radio spectrum. This enables a fixed number of channels to serve an arbitrarily large number of subscribers by reusing the channels throughout the coverage region. So the cellular concept allows every piece, as you can see here, every piece of subscriber equipment within a country or continent to be manufactured with the same set of channels, so that any mobile may be used anywhere within the region. It's like more to roaming, something like that. So we move on to cellular architecture. So this is, as you can see, this is the cellular architectures. It consists of ideal cell, features cell, square shape, cell site, database, mobile switching center, and PSTN. So it includes mobiles as the user, base station, switching center, which is we call it as MAC, and also interfaces to PSTN. Sorry. Okay. So this is a little bit explanation or definition about base station. It includes an antenna, a controller, and a number of receivers. It's often one base station controller that controls multiple BTS. So one BSC can control a lot of BTS. Mobile telecommunication switching office, or we call it MTSO, connects calls between mobile units, also called mobile switching center MSC. The two types of channels available between mobile unit and BS is control channels and traffic channels. So the control channels used to exchange information having to do with setting up and maintaining calls. For the traffic channels, carry voice or data connection between the users. So we move on to the last part of our presentation is frequency reuse technique. So each cell has a transceiver base. The transmitting power is controlled to avoid interference with neighboring cells, and the same frequency is used in non-adjacent cells. So this is the cells. The illustration of the cellular frequency reuse concept. Cells with the same alphabet use the same channel set. So the same alphabet will use the same channel set. Okay, sorry. So the total available channels are divided into a number of channel sets. The frequency reuse pattern is equally to the number of channel sets. Each channel set is assigned to a cell. Cells are assigned a group of channels that is completely different from neighboring cell. The same set of channels can be reused in another cell provided that the reuse distance d is fulfilled, like in the figure 1. This one. The reuse distance is the minimum separation of identical channels that have the same carrier frequency, at which there is acceptable interference using the equation this, where n is the number of channel cells in cluster, r is the radius of cell. So that's all from our group about cellular concept and architecture, and also the frequency reuse technique. Hope you can enjoy our video. Thank you.